Okay, I started recording. Let's start today. Before that, are you really only 4 students hostelite? I mean, the rest are all in DL mode, or they are in quarantine, or they are in hostel and in DL mode. They don't want to come. Very late. Okay. Ah, okay, okay. Say. Okay. Okay, right. So most of you are in DL mode now. So today for today's class, because this happens every week. So okay. Okay. So we have ample audience. We have 30 students in the DL mode. Let's start. Um, so we were here. This slide set, we started discussing the application layer yesterday, and the important things that we discussed in the yesterday's class was the principles of network application, in which we discussed two concepts. One is what type of service is required by an application. Categorizes those services into 4 categories: data integrity, throughput, timing, and security. And we said that there are some applications who require um, uh, data integrity and security, and there are some who require throughput and timing, and some applications so mostly applications do require some or all of these characteristics. And then we saw in this slide that what are the service models available for that. And we saw that at the transport layer there is a clear dichotomy. We have two service models available. One is a protocol which has a full set of features, which is TCP, transmission control protocol, and another protocol, UDP, which is a bare minimum which is a bare minimum transport layer protocol. And we discussed their features as well. We saw their service model. We will have this discussion in detail in chapter 3, transport layer, as well. But for now, we at least have a gist of how an application can make a choice of which transport layer protocol to choose. And at the very end of the lecture, we were discussing something very important, that why bother, why is there a UDP? And I was giving you guys examples of a few important protocols, DNS, SNMP, and DHCP, which uses UDP, not TCP. They uses UDP. And today we are going to start discussing one of those important protocols, which is DNS. So continuing from where we left yesterday, if I start discussing the DNS, which is domain name system, this is topic 2.5 of Kuros and Ross. Okay, right here. Um, this one you can see. Uh, Okay. We will only discuss these two applications, okay? DNS and HTTP. That's it. Nothing. No other applications we will discuss because obviously it's not a UG level course. So we'll move forward. So this is a funny way of illustrating. Uh, if you guys know this, most of you know this character, right? Dwayne Johnson's, aka The Rock, right? He's a famous movie star and a famous, you know, um, wrestler as well. So he's asking that what is your address, and the guy is replying 192.168.1.254. So he's just looking behind in in a very surprised way, because this is not the way human give addresses. The point we are trying to make over here is that host names which are being used in the internet are mnemonic to us. Mnemonic means they are easily memorable to us. So it is easy for us to memorize www.yahoo.com as compared to something like 10.255. Something dot something. Okay, it's not mnemonic for us. For us to suit our memory, host names are more mnemonic. So obviously it's like the mapping of names to phone numbers in our phone directory. So whenever we scroll in our phone directory, in our contact list, we touch or press the contact name, and at the back end the number is going to be dialed. Very common example. We do that daily. So it's like name to phone number mapping. It's like a small DNS system of inside our phone, so our phone directory. Okay, so we like to memorize people with their names. Not I would say it's Talha sitting over here or Abdullah sitting over there, not their passport numbers or their CNIC. Right? That's not mnemonic for us. Okay, so similarly for the people, the host names are more mnemonic like this. They are easily memorizable, and but the machine, they need the IP address. So how to map IP addresses to names and vice versa? We need the DNS, the domain name system, to do this job, and it's an application layer protocol. And just like I explained you guys yesterday, that it is one of it is a very unique application layer protocol, which is invoked not by the user themselves, but by the application which is invoked by the user. So we as a user invoke file transfer protocol or hypertext transfer protocol or mail transfer protocol, and those protocols then invoke DNS, because the user has just entered mail.google.com. But where is this mail.google.com? So to get the host name to IP address mapping, the SMTP, the simple mail transfer protocol, invoke DNS to find that IP address for SMTP. Okay, so it is something like that, which is being shown on the right of the screen. Okay, in this example right here. So if you notice, it's a very simple process. I'm a bit fast in the early slides because I know that you all of you must know the basic working of DNS. I'm sure about it. Okay, so I will be a little bit fast in the early slides. So if you noticed, the user, it first as the first step, this right here is the first step. The user entered the host name, and user is interacting with this particular protocol. User is interacting with FTP, the file transfer protocol. So in front of user is the file transfer client. Okay, there is a file transfer server somewhere in the internet which has the file which the user require. But right now in front of the user, this is the file transfer client, and this is the whole application layer. Okay, right here. So the user is invoking the file transfer client, that this is the host name. I want to get a file from this host name, but the file transfer client needs the IP address, because with the IP address, it will, it will, knock at the transport layer, at the TCP, that this is the IP address and this is the port number 21. I am FTP protocol, and I want you to create a socket and a process so that I can, communicate with the help of that. Okay, but to do that, it needs the IP address, and to get the IP address, as a second step before TCP, the FTP will first invoke the DNS client at the user end. Okay, so as the second step, it will ask the DNS client. So the whole process is at hold right now. If you notice, FTP cannot contact TCP. The process is at hold. It gets the message from user, but to contact TCP must have the IP address, and to have the IP address, it contacts the DNS client. And at the third step, the DNS client query to the DNS server. As a fourth step, there is a response. So the query is, I want to find the IP address of this host name, and the response is, okay, for this host name, this is the IP address that I have, and this is the query and response. And by the way, right now we are saying that this is a DNS server, which is, we are treating this process as a black box, but it is not that simple. There is no server in the world who has responses for all the queries. So if there could be a case when the DNS server don't have the definite answer, then we will explore in the future slides what will be done. But right now, let's treat this process as a black box. This step 3 and 4, that the query and the response is received, and when the response is received, the IP address is being forwarded from the DNS client to the FTP, and then the FTP, with the help of this IP address, will contact the transport layer and the rest of the process. The transport layer, the network layer, the data link layer, and then the packet will appear on wire. Okay, so this is the a small process which happens, and we can say that this process is somehow we can call it as the DNS resolution process at client end. Okay, client end. We are using this step 3 and step 4 right now as a black box. It is not that simple. We will explore it further in the coming slides. Okay, so what is a DNS? On the left side, it's written the properties, the salient features of DNS. It's a client server paradigm. Okay, in DNS we have a client who will query and a server who will respond. It is a distributed database. DNS is implemented in a hierarchy of name server. Now is not the time in internet that we can have a single DNS server somewhere in the globe and all the entries of host name to IP address are being stored in that server. This is not possible. It was possible in the early 80s when the internet was very small. Okay, and there used to be a single server in California, in Stanford, who was considered the database of internet names, and in that server there was a file host.txt, and each and every this thing is written over here, right here, you see, right here, host.txt file. Okay, and each and every machine on internet, when it want to connect to the internet, it contact this server and get this host.txt. But you know there are certain problems. These are all the problems which are going to be arise, and the problems are, how do you maintain if the internet grows? There is a single point of failure. If that server went down, the whole internet will be in the black box. Okay, and then the traffic volume, obviously with growth, you will not be able to sustain that much traffic volume. And then distant centralized database, where to put that database? If it is in California, then there will be a huge propagation delay for the users who are here in Asia or in Africa or somewhere else. So distant centralized database. So the answer to all these problems as the internet grows is this one, which is written right here. Nowadays, the DNS is a distributed database. It is implemented in hierarchy of name servers. Okay, so there are name servers who have their certain functions, and in the coming slides we will explore it. Okay, so these are the salient features. It's a client-server paradigm. It's a distributed database. It is an application layer protocol, obviously, right, which is used to resolve the names, and it is a stateless protocol. Okay, there, whenever a new application is comes into your mind, there are few questions. There are few very common questions which are being asked: whether this application lies in client-server paradigm or peer-to-peer paradigm, whether this application uses TCP or UDP, what is the port number of this application, and another important question is whether this application is stateful or stateless. Okay, so DNS is stateless. What is meant by stateful or stateless? A stateful application, it's maintain the record of any interaction of the client. For instance, HTTP itself is stateless, but HTTP, when cookies are used with HTTP, it became stateful. And you have noticed that modern day internet is full of cookies. Most of the websites, they use cookies to improve user interaction. Although it is considered as a privacy breach, that is why there is a very small message always popped up whenever you visit a new website, that we are using cookies to enhance the user experience, and do you agree or not? And by continuing the use of website, you actually agrees. This is also written in the message. So if you click somewhere, the popped up message disappear, and you have actually agreed. So you have to explicitly either say no. If you don't, you either click on OK, or you click on somewhere else on the web page, then it's a yes in any case from your side. Okay, because with cookies, what they want to do is that they want to maintain a state of you. So whenever you visit a website, you have noticed that this website recognizes me. I mean, as if it notices what I did last time when I visited this web page. So, for instance, Amazon.com, or the version of the Pakistani version of Amazon, Daraz.pk. Okay, when you visit there, if you search last time for T-shirts, you may start having pop-ups, ads of T-shirts, things like that. So the point I'm trying to make is, this is a stateful behavior. But DNS, if a DNS client sends the same query to a DNS server repeatedly, that what is the IP address of CNN.com? What is the IP address of CNN.com? What is the DNS server will never reply that you have already asked this IP address. It's a stateless. And why it's stateless? Why it is on UDP? Answer to everything when it comes to DNS is to make DNS fast. Making a stateful protocol is much slower as compared to a stateful answer will require a server to look back into the database, fetch the cookie, see the cookie for the previous sessions of user, and then give a stateful response. For DNS, as we discussed in the previous lecture, it works on TCP, it works on UDP instead of TCP, because to make DNS fast. And making DNS fast will make the whole internet experience of user fast. So that is why DNS is also stateless protocol. It is not stateful, because making it stateful will again hamper the speed of the DNS. Okay. what is the services that DNS do? Obviously, the most important service for which DNS was actually, um, presented or and made part of the internet was the host name to IP address translation, definitely. But other than that, there are some other important services which DNS perform. For example, host aliasing. There are canonical names being used. So for instance, if you remember when we were trace routing www.polito.it, okay, www.polito.it, the actual name was webfront-01.polito.to.it, something like that. It was a uh, very long name, and this name is not easily memorizable and not mnemonic to the users. Okay, user would like a simple name, ibm.com, not server is dot something dot ibm.com. Okay, so these are all canonical or aliases, right? So the DNS also translate canonical name to simple host names. Okay, then there is mail server aliasing, because if you want to get IP address of mail.yahoo.com, mail.google.com, something like that, then there is a mail server aliasing. And then there is another thing which the DNS perform, modern day DNS. It is a load distribution. So I will for that I will write something on the slide. So for instance, let's suppose we want to there is a client, and the client want to visit there's a machine host A over here. uh, After the example, I will take the chat. I will take the question in the chat message. Okay, there's a chat message I noticed, but just wait a minute. So we can assume that there are several nodes in the middle. Okay, let's say there is a whole internet cloud over here, and then there is a server right here. There's a server, and it's not actually a server. There's a data center over here. Okay, there's a data center DC. Okay, and there are plethora of servers. Tens of servers being placed over here. Okay, and all these servers are serving CNN.com. Okay, and let's assume that the servers have IP addresses of something like that. You see 34.10.10.80 and up to 34.10.10.90, something like that. Okay, something like that. Okay, you got an idea what I wrote over here. So there are 10 servers, and they have the IP address of 34.10.10.81 to 34.10.10.90. Okay, there are 10 servers. Okay, so what the DNS will do, the DNS will distribute the load cleverly. So there is a DNS server over here also, and this DNS server is responsible to translate the queries for the host for the domain name CNN.com. So anything which falls under CNN.com, this server will translate all these queries. Okay, so if any request come from around the globe and the server is asking the IP address, it will reply to the user that this is the IP address of CNN.com. Then another user will ask, okay, it's a very famous website. People will keep hitting this website, and I've already told you guys that modern day internet, the most famous websites are usually served with the help of tons of machines, data center, not with the help of a single user. Okay, those times are gone. So the next user will ask, and it will say the same question, but the answer is different. The question is, which is the IP address of www.cnn.com, and it will say the IP address is 34.10.10.81. And the next user will ask, and it will say it is .82. The next user will ask, it will say it is .83, and up to so on. And in this way, by responding to users with different IP addresses, it is actually distributing the load among replicated web servers. So these are replicated web servers, all doing the same thing, all serving the web page of www.cnn.com. But because it is so famous website that there will be many users requesting for that web page, the service is replicated among different web servers. And obviously, because all of those are distinct machines, so all will have different public IP addresses. So what will the server do? Will it save just one IP address? No, it will have all these IP addresses against a single host name, but it will cleverly distribute the load among all the machines for all the users, for the requesting users from around the globe. Okay, so a DNS server performs all those services. Okay, let me take the question in the chat message. What is the difference between host name and aliasing? So command prompt. Okay, I am trace routing trace RT www.polito.it or ping even. You see here the actual name is webfront-01.polito.it and IP address is 130.192.181.193. Okay, this is a canonical name. This is a name that the this is a name. This is you can say that this is a name which is not used as a front name to the common public, to the common internet users. This is a canonical name which is being used by the administration of the Polytechnico to for their own server administrative purposes. Okay? But that's the actual name of the server in their books. But what will be presented to the normal internet user will be the name www.polito.it, which is very simple. So, for instance, IBM.com. Why is this? By the way, not trace routing, although this is not our topic today. But let's see. You see, wow, it's very different. E2874.dscx.akamai edge. IBM is using the services of Akamai. Akamai is a content distribution network. Just like YouTube is using the service of Google, IBM and Amazon and many others use the service of Akamai. By the way, Akamai is a CDN giant. It's a leader in the CDN industry, okay? Just like Google. So you see, the address is something like that. So we want to visit IBM.com, but somewhere in the Akamai cloud, IBM is being served because IBM is the client of Akamai. Okay, so the address is e2874.dsc. This is another use of the canonical names, by the way, because canonical names are useful when the actual name is the service provider and the service is being provided by the CDN. The CDN will have their own name of the server, right? So the Akamai is using their name of the server, and they cannot name their server on on IBM domain, IBM.com. No, their server will be named akamaiedge.net. Okay, something.akamaiedge.net. So you notice, okay. And I love traceroute, so I always started visiting what is over here. You see, it's we went to Marseille. Oh, it's very weird. We went to Marseille and we went to Transport, then we went to Marseille, and then we went to Mumbai, and then Delhi, and then so Akamai has a node in India. Akamai has a node in India, but Pakistan is not taking a direct route to India. Pakistan is being routed to India via Europe, via France. We went to Marseille. We used the Trans World Tier 1 ISP to get out of Pakistan, and then we entered Europe with the help of level 3 Tier 1 ISP, and when we went wow, you see, not always the geographical shortest path are true in the internet. The internet routing rules are governed by BGP, Border Gateway Protocol. We will study in chapter 4 in the Cross and Ross. So we will see that the BGP, it takes into account all the policies, including the government policies and all those things. Wow, that's very interesting, by the way. This is very interesting. So the node is in India, but yeah, obviously. By node we mean a server. By node I mean a data center. Obviously inside a data center there are many servers and one of those servers is serving. So Akamai has a data center in India, but not in Pakistan. Okay. If it would be in Pakistan, the PLT would be much less compared to this. It's 392 millisecond being reported over here. If it is in Pakistan, so for Indian users, someone sitting in Delhi wanted to access IBM.com, the answer would be, I don't know, 20 millisecond maybe. Understand? We should have CDN nodes inside Pakistan. We should have at least the giants: Akamai, Limelight, Google, Microsoft, and these companies. We should have CDN nodes. I don't think we have CDN nodes, which means data centers in Pakistan, or for that matter, maybe the node density will be less in Africa as well. Anyway, I always, this is one of my favorite topic, the internet delays. I always used to switch. Coming back, so did I answer what was asked over here? What is this? Can't really see Mumbai. Not showing in my. It is possible. I'm going out with the help of Pern. Pern will go out with the help of Transworld and Level 3. Okay, this I am sitting here in an educational institute. You are, where are you? You are using Neatel. So that's a whole different story over here. Okay, you might be using a different node. Okay, we cannot tell, but again the discussion will shift. The point I'm trying to make is that the routes are governed by BGP. Okay, the routes are not governed by simple geographical distances, just like we used to travel between cities. Okay. Another question is alias means AKA. Yeah. Okay. It's like that. So it's just a name that to be used. Yes, exactly. That is correct. And what else? These 10 addresses point to the same CNN.com server. Yes, in my example, all the 10 addresses point to CNN.com server, not the same server, to 10 distinct machines, but all serving the same content. Okay, because it's a popular website. So this is very common. By the way, there
सर
are
ये
still
बात
2 minutes.
दोबारा समझा देते हैं।
कौन सी वाली बात? Which
10
which
IP
thing?
एड्रेसेस वाले, ये
10 IP
10 IP
addresses.
एड्रेसेस CNN को जब हम रिक्वेस्ट करते हैं तो वो 10 IP एड्रेसेस जो में से कोई एक हमें जो एलोकेट करता है इन रिस्पांस, वो IP एड्रेसेस DNS सर्वर के 10 सर्वर्स के हैं या CNN के सर्वर को पॉइंट करते हैं, ये समझ नहीं है मुझे।
Let me repeat. No. Those IP addresses uh, uh, I should repeat the question in English first. Sorry. Well, he's just asking to repeat the concept of replicated load distribution. So no, that the DNS server of CNN.com will only have one IP address. Okay, so that's the IP address of that particular DNS server. Okay, but the content will be provided by many different servers. Okay, and because the request is most how do I put? So the servers who are more occupied, so the DNS server do not maintain any connection because it is working on UDP. So a DNS server can most likely serve more number of users. Okay, there may be different DNS server as well. Now the detail will get more complicated, but the user will be pointed towards. In my example, I am saying that there is one DNS server which is solving the authoritative name of www.cnn.com, and the content is placed in many servers because the request for the content is more common, and it will be on the HTTP, which is using TCP. Okay, so the connection will be maintained, and there will be the load of a single user will be more as compared to the load when DNS query will be performed. Okay, and in that example, what I'm saying is that the DNS server will cleverly point each coming user to different machines. Okay, having having different IP addresses. So the question, there will be a question from a user in Islamabad that what is the IP address of CNN.com, and the reply will be that 10.81. There will be a question from a user in Gambia, what is the IP address of CNN.com, the reply will be 10.82. There will be a question from the user in Sydney, the answer will be 10.83, things like that. All servers are serving the same content. Okay, this is called load distribution, right?
Sir, अगर
Yes.
Sir, if the
Yes.
same IP address is allocated by all the 10 servers, तो उससे क्या load balancing नहीं होगी, क्योंकि हम हर server individually different users को address कर रहे हैं।
Can you please repeat the question? Can you please repeat the question?
Sir, can you hear me?
Repeat kindly. Ali?
Sir, आवाज आ रही है?
जी आ रही है, repeat कीजिए please.
सर फॉर एग्जांपल एक यूज़र गैम्बिया से रिक्वेस्ट कर रहा है CNN.com और दूसरा यूज़र इस्लामाबाद से रिक्वेस्ट कर रहा है, ये दोनों रिक्वेस्ट डिफरेंट सर्वर्स DNS सर्वर्स के पास गई लोड बैलेंसिंग की वजह से, और एक ने 81 का IP एड्रेस दे दिया।
You muted yourself in the middle of the question.
सर खुद ही म्यूट हो जाता है, आई डोंट नो।
अच्छा
सर अगर दोनों को रिप्लाई जो
they are not liking your question, please don't do that. Don't do that. In MS Teams you can mute each other, you can mute me if you want. you can kick someone out of the meeting. Don't do that. Act maturely. I know for those. Let me be very blunt and straightforward. For those who have got the concept, they want me to move forward. Obviously, I want to move forward, but I have to respect every question. So this is even wasting more time. So let the student ask his question very quickly, and I will be very quick in the reply, and we'll move forward. Please, Ali, complete your question. Jaldi.
The different users अगर request करें and if all the DNS servers reply with the same IP address, तो उसमें भी तो load balancing हो जाती है. Why are all the servers replying with different IP addresses?
When they will reply with the same IP address, the public IP address is unique and distinct in the entire global internet. If they reply with the same IP address, this is not load balancing. The users will contact the same IP address, .81. Yes. Okay, that's a different concept. You guys are going into too much technical details. That is called IP anycasting. IP anycasting is something in which, so you see, someone, the student who muted Ali Amjad, an interesting concept came out of his question. Okay, and the discussion of, I forgot your name. Jamal, and the discussion of Jamal. So the thing is, IP anycasting is a concept I will not discuss in detail. There will be a portion of the lecture in future. IP anycasting is something which the CDN used, in which the same IP address is being assigned to different servers which are dispersed over the globe. And so, for instance, if the answer is if I go back to the slide, if the answer is 10.80 all the time, okay, but the 10.80, so 34.10.10.80, that server, one of that node or data center is placed in Singapore, and the user in the close vicinity are directed towards that. Another one is placed in Sydney, and the users in close vicinity are directed towards that. This is called the concept of IP anycasting. So there are different types of casting. Okay, unicast, multicast, broadcast, and anycast. We will study that in when we will go to the network layer. And IP anycast means that the same IP address is assigned to different distinct devices over the internet. Okay, which is weird because we used to say that the public IP address is unique. Okay, but when we do IP anycasting, then the DNS is responsible to avoid the conflict for user. Okay, the DNS is clever enough that the users requesting from India and Pakistan, they will point those users in the direction of Singapore, and the users requesting from, let's say, Africa, they will point those users in the direction of, let's say, a server or node placed in South Africa or some other country. Okay, so the DNS is clever enough. Okay, but in anycasting, one IP address is mapped to many devices. In unicasting, one-to-one mapping, multicasting, one-to-many, broadcasting, one-to-all, and anycasting, one-to-any of the devices. So yes, it is possible, but this is not the example I gave. The example I gave is the example in which under a single roof, there is the DNS server and many servers of CNN.com, okay, a data center basically, and then users from around the globe are requesting that DNS server, and the DNS server is cleverly, replicating, distributing the load among replicated web server. Okay, let me move forward, G. Okay, so next, okay, so we discussed in one of the slides that the DNS is a distributed hierarchical database. Okay, so this is the way it is distributed. You can see the hierarchy. So there is, on top of everything is the root name server. Okay, right here. Okay, then there are the top level domain name servers. Okay, these are all the TLDs. These are all the TLDs, top level domain name servers. Okay. Okay, and the TLDs are mostly .com, .edu, .gov, .net. Okay, and then there are top level domain name servers of the countries themselves, right? So, for example, for Japan, for UK, for Pakistan, for Netherlands, and Australia, and okay, all the countries. What is the TLD for Gambia? Dot gm. So all those, okay, lies over here, right? So there is a single root name server, okay, and then the root points the users, the requesting users. Now please remember, now we are going to explore this step, this 3 and 4, okay, which previously we used as a black box. We said there is a DNS query, there is a DNS response, but What if we are sitting right here and we ask the DNS server of Seeks, you know, Seeks DNS servers of Seeks that, let's say, what is the IP address of www.crickinfo.com, and it does not have the IP address already in its record, in its DNS table, then the Seeks DNS server is going to follow this hierarchy. It will request root name server, and the root name server will then point in the direction of .com, okay, over here, and then the .com will point in the direction of crickinfo.com, and then the crickinfo.com will reply with the final definitive answer. So for instance, let's have an example over here. Let me just zoom out to have a view of the whole slide. For example, you can see over here, and now also because of this hierarchy, the host name actually speaks about itself. So if you notice, robot.cs.washington.edu speaks a lot about itself. So it says that, okay, I'm a university basically because I falls under the Azure domain, okay, and then this over here is something which is under the authoritative domain of washington.edu, okay, and that is basically a specific machine inside the CS department of washington.edu. So if you notice, this address, this host name came into play because of this hierarchy. So robot.cs.washington.edu, okay, this hierarchy right here, okay. And for example, here you can see titanium.6.edu.pk. So for instance, if there is a local name server, this titanium machine wants to access this robot machine over here, then the titanium machine will ask the local Seeks local name server, Seeks DNS server, what is the IP address of robot.cs.washington.edu, and it will say, okay, I don't know the IP address. The local name server will then contact the root will then point in the direction of edu, the edu will then point in the direction of Washington, and the Washington will then give a final answer of, because everything under Washington is the responsibility of authoritative name server of washington.edu, okay. So these are the three name servers which come under hierarchy. So to put things into summary, okay, DNS is a distributed database, and it is distributed in the hierarchy of three name servers. One is the root name server. The root name server points in the direction of the TLD who is responsible in the name resolution, and then the TLD points in the direction of the authoritative name server that is responsible for the further resolution, and the authoritative name server is responsible for a particular domain. Okay, a particular domain means cisco.com, ibm.com, nus.edu, okay, .pk, and things like that, okay. So any machines under that are being served by, so anything under washington.edu, for example, engineering.washington.edu, robot.cs.washington.edu, anything under that is the responsibility of this authoritative name server, okay. Now a question comes into our mind that I mean, we started our discussion that early 80s there was a single machine which was the DNS server. Then now we are saying that it's a distributed database, but there is a root name server. So the root name server also offer a single point of failure, isn't it? But that is not correct. The root name server, don't think it as a single machine in the internet. The root name server is actually something like that. Okay, there are 13 root name servers in the world, and by 13 root name servers I mean 13 different organizations who have many instances of root name servers. So for instance, I take an example of ICANN. ICANN is a very famous organization, and you all know about it because ICANN is right here. It is one of those 13 organizations. ICANN stands for Internet Corporation of Assigned Names and Numbers. This is the organization who is responsible for the entire internet, IP address space, and DNS addresses and all those things. ICANN falls under IETF, Internet Engineering Task Force, which is the main governing body of internet, okay, responsible for the well-being of internet. So ICANN is the Internet Corporation of Assigned Names and Number, and if you notice, ICANN has 41 other sites as well, okay. It is headquartered in Los Angeles, California, but it has 41 other sites as well. And by the way, one of those sites is is in Lahore as well, okay. I'm just going to finish because Dr. Asim is here. I have some questions. which I'm going to take to the next class, okay? Because Dr. Asim is here for the next lecture. So so this is the concept of root name server. Okay, I will share the slides and we will start from here. Okay. Okay. Any quick question? Almost the same because it's a lot of reading to do. Okay. I'll get back to this question. Okay, later. Mustafa and Wakas Ahmed. I'll get back to this question later. Okay, or I'll reply in chat over here. So I'll conclude right now because the next lecture is going to be started. So thank you. Let me stop recording.